Hi, this is Tom Salemi of Device Talks. Welcome to the Intuitive Talks podcast. Surgical robotics presents an enormous opportunity for companies. There are surgeon shortages, sporadic healthcare, and miraculous technological advancement in both robotics and communications. So to understand where this sector is headed, we invited senior executives from Intuitive to share their company's impressive story. Change is coming. Consider these upcoming episodes to be guideposts for the future to follow. Hey everyone, this is Tom Salemi. Welcome back to the Intuitive Talks podcast. We've spent a lot of time talking about Da Vinci, as we should, but in this episode, we're going to focus on Intuitive's other groundbreaking robot, the Ion endoluminal system. We speak with Charlie Dean. He is Vice President and General Manager of the Endoluminal Business Unit at Intuitive. He's an engineer who has spent his career working to make smaller and more effectively minimally invasive tools. And I also have the opportunity to speak with Dr. Oliver Wagner. He is Vice President and Medical Officer of the Endoluminal Division. And he explains how his longtime pursuit of notes led him to join Intuitive. So it was a great conversation. I really enjoyed meeting these two gentlemen, and I know you will enjoy this conversation as well. All right, well, before we begin this episode of the Intuitive Talks podcast, I'd like to bring in our sponsor, Maxon. Maxon, of course, is a worldwide leading provider of high-precision drive systems, and it's a longtime partner of Intuitive. I'm joined by Peter Van Beek. Peter is Business Development Manager for the medical group at Maxon. Peter, do me a favor. Tell our listeners about Maxon.
Sure, Tom. Maxon is a Swiss-based, privately held global company. And at our core, we are an engineering company that develops and builds world-class electric drive systems and electronics. What's nice about our product line is you can piece it together however you like. It's modular. Do you need just a subfractional DC brushed or brushless motor, or a servo assembly consisting of a motor, a gearhead on the front, a sensor on the back, and a controller? In other words, a complete mechatronic drive system. We provide standard catalog, semi-custom, or fully customized assemblies, even building complete from scratch rotor and stator assemblies. Maxon does not shy away from cutting-edge technology to solve the impossible drive application, be it a Mars rover or a helicopter drone, or in Intuitive's case, a surgical console haptic motor.
That's great. Thanks, Peter. We'll find out more about Maxon a little later in the podcast. But if you'd like to find out some more information right now, you can go to maxongroup.com, MAXON group.com. Now, let's begin this episode of Intuitive Talks. Well, Charlie Dean and Oliver Wagner, welcome to the podcast.
Good to be here.
So I feel like I have an apology to make. We've been talking about Intuitive for the last 3 episodes, and I've always just kind of thought about Da Vinci, Intuitive Da Vinci, and I've given very little attention to Ion. And I'm glad now we can finally shine the bright audio light onto Ion and what you do. I've brought myself up to speed, and it really is very, very cool product and technology. So before we get into the tech, though, I'd like to understand both of your paths to Intuitive and into the industry. Charlie, why don't you go first? Give us a little bit of background about yourself.
So England, born and bred, mechanical and manufacturing engineer by training. I actually started designing medical devices, class 1, 2, 3 combination. Quickly found the sort of minimally invasive space was not only the most interesting to me, but also sweet spot for the time. And so I worked for a number of companies from, the likes of Pfizer and Johnson & Johnson down to small one-man startups, designing a whole range of minimally invasive products. That was about the time that cardiovascular stenting took root. So I had that for a number of years, then went on to work in almost every space, laparoscopic surgery, did a startup after I'd moved to America, which was endoscopic surgery. And that's really, and in fact, Oliver and my paths sort of crossed there because that was the rise of NOTES, natural orifice surgery, sort of 2007 sort of period.
Sure.
That startup was super interesting. I mean, at that point, we were trying to move, from open and laparoscopic surgery all the way to endoscopic surgery. Interestingly, at the same time, that Da Vinci was trying to push laparoscopic surgery to robotic surgery. So obviously I knew of the space and knew of Intuitive. The endoscopic surgery company, eventually went public, and I moved to Intuitive really because I thought that the next step for those things was that endoscopic and robotic surgery needed to combine.
Oh, neat.
And obviously you can see how, one, I ended up Intuitive, and two, how I ended up with Ion. So it wasn't exactly that thought through if I look back 25 years, but it's been all minimally invasive surgery. And I really think that that's the future. It's where we need to go. We have to find a way of making it less invasive, and we'll be able to operate on more patients earlier and extend life. I think that's what it's all about.
That's terrific. I'm just curious, as an engineer, what was it about minimally invasive technologies that appealed to you? Is it the miniaturization? Is it just the complexity of what goes into the designs? What really resonated with your engineering self?
Yeah, it's harder, is what you're saying. And that's
you're a masochist, is what, yeah,
something like that. It's the challenge, right? You have to get things that are inherently simple, because otherwise they're too big, too clunky, too difficult to use. It really forces the mind. That's why it's not proliferated yet. But it's also kind of cool space because the tech's evolving so quickly in the space. Cameras are getting smaller, chips are getting smaller, parts are getting smaller. Like it's right at that point where you can really take the advances in tech and apply them to medical. So it's the masochist in me.
Fantastic. And Oliver, let's bring you into the conversation. Please let us know how you got into medical devices. You're a physician by training, and you practiced for a time.
I am. I'm actually a surgeon by training. I also was born in Europe, in Germany. I am not an engineer by training. Never did I do anything engineering at school. I always wanted to become a surgeon. I'm a surgeon. I started my career med school in Germany, started my residency in Germany. Back in the day in the university in Düsseldorf with the vascular surgery department, very famous back in the day for big open surgery, thoracoabdominal aortic replacements. That was very exciting, 12-hour surgeries. The problem I always recognized was those patients had surgery. They were cut open from the shoulder all the way down to the hip, basically, across the abdomen. So big, invasive, open access surgery. The patients did very well in regards to the surgery itself, the aortic replacement, but they suffered for weeks, if not months, from the access. From there, I moved on to Switzerland, spent 7 years of my early surgical career in Switzerland, training, later became an attending surgeon. And the same topic here. We did a lot of abdominal or visceral surgery, open surgery, liver transplant surgery, and patients did well. But what didn't resonate with me was still the very invasive open access. And I drove into more minimally invasive technologies already then and specialized in minimally invasive technologies. The next step was conventional laparoscopic or thoracoscopic surgery. And then, as Charlie mentioned, there was a new wave coming up and said, why do we even need to do cuts in the skin? Why can't we use natural orifices to do surgery? And there was a team in Europe and Switzerland next to a team here in the US that was driving that very quick and very fast through preclinical testing into clinics, so using it in humans. So we did transvaginal surgeries. It required a lot of training with conventional endoscopes to get the skill set to do that type of surgery. So it was clear back then that we need the support of industry to build more sophisticated technology to allow us to do these procedures more routinely and decrease the tremendous learning curve over 100 preclinical procedures. And that was, in the end, what brought me here to the US, where we joined forces with another nodes team. And we wanted to continue the development, work with industry to advance that technology. And back in the day, as Charlie mentioned, that was around 2007, 2008, industry wasn't really tapping onto that new technology quite yet. They said, maybe too risky, you don't know. People supported us with mechanical devices, but it became clear pure mechanical device is not sufficient for the task that we are confronted with. We needed a system that is flexible when we need it to get through all the tight bends and turns. If you imagine going through the mouth, down into the stomach, making a little hole, then turn around and look at the gallbladder. And then at the time you want to apply force to the tissue and dissect tissue, you need the system to be as rigid and stiff as possible, right? Things that were really difficult to accomplish with a conventional endoscope. And it became clear to me we need more sophisticated technology to be able to do these tasks. Since this wasn't resonating with industry back in the day, I went back to robotic surgery, joined the foregut and thoracic team in Seattle to help them bring up the robotic program in the chest, trained on thoracics and foregut surgery. Was a very exciting team, and that's what brought me closer together with Intuitive. We wanted to do types of surgeries and ask Intuitive who else has done that type of surgery in the world. And they said, nobody invited us down here. We figured it out, learned different techniques, and applied them back in the hospital to our patients. And this is how I started working and consulting with Intuitive until eventually I found the endoluminal ion technology in its infancy. I would say that was about 2012. And started consulting. I felt there is a need for this kind of technology. My old ideas of having a more advanced, flexible system came back up, and it's like, oh, maybe there's a there here. We need to support that type of intervention. And ever since I increased my work with Intuitive, became now the medical officer for the endoluminal team, and took a more permanent position with Intuitive. And it's been a very exciting journey ever since.
Well, that's great, Oliver. Let's take the story back a bit. You mentioned the origins of Ion. Take us back to those origins. What were they? And kind of walk us along Ion's history a little bit. All right, we'll take a quick break from this conversation to bring back our sponsor, Maxon Group, and Peter Van Beek. Peter, I know Maxon can be found in many medical devices and applications. Can you share some specifics?
Sure. Maxon was actually one of the first motors in atherectomy devices, which was a disruptive technology in the early 2000s. It was actually replacing pneumatic power. But some other applications, Tom, would be dental tools, heart pumps, ventilators, surgical power tools used for brain, knee and ankle, or hip surgeries, insulin, dialysis, drug delivery and feeding pumps, lab automation, respirators, and last but not least, surgical robotics like end effectors, haptics, tensioners, etc.
Interesting. And how has Maxon been involved with surgical robotics historically? And what are some of the changes that you're seeing with modern surgical robotic drive systems?
Maxon has supplied drive systems to the surgical robotics industry from its inception, starting in the 1990s with Stanford Research Institute's Golden Hour robotic system and Intuitive's first and up to the present systems. For nearly 30 years, surgical robotic companies worldwide have been placing their trust based on our design and development expertise, be it a multi-port, single port, or catheter-based robotic system. We supply the haptic, cable tensioning, and end effector drives and electronics. Concerning the future, Maxon continues to push the envelope with drive systems which are smaller, more power dense, efficient, quieter, and having low inertia, specifically for haptic.
That's great. And final question, Peter, what are some of the advantages that Maxon drives offer medical device developers?
Tom, let's start with quality. We're accredited to quality standards ISO 9001 and 1345. Maxon has recently restructured and streamlined our quality systems to align with European MDR and FDA regulations and validation requirements. Surgical robot makers who bring their projects to Maxon will have the benefit of working with engineers at all levels, sales, project, and R&D. In close collaboration with our customers, we develop drive systems tailored to the customer specifications, using modifications both simple or complex. We can make fully customized mechanisms, for example, end effectors with drive electronics and motor assemblies. We have autoclavable motor and gear options, hollow shafted motors, right angle gearboxes. We have attachable gear heads of all types and ratios, and even a new ultra performance gearbox that can be back driven. Regarding sensors, we have optical and magnetic based encoders and drive electronics to fill it out for both speed and torque or positional control.
That's terrific. Thanks so much, Peter, for joining us on the Intuitive Talks podcast. And thank you to Maxon for sponsoring. If you'd like to find out more information about Maxon, you can go to maxongroup.com. Let's take the story back a bit. You mentioned the origins of ION. Take us back to those origins. What were they? And kind of walk us along ION's history a little bit.
So on the one side, right, there was this amazing technology. Now we needed a clinical application. This is where I could help. Back in the day, I came from practicing with a thoracic and foregut team in Seattle, and lung cancer was in the forefront of our minds. Lung cancer still until today kills someone in the US about every 4 minutes and remains the number one most deadly cancer killer in the world.
Wow.
There are about 1.8 million deaths, I think, last year in the world, patients that died of lung cancer. What we do know is lung cancer survivability improves with early detection. So the sooner we find lung cancer, the better is the outcome. The problem is early lung cancers don't produce any symptoms. We don't know that we have a growing mass in our lungs. And for that reason, it's usually not detected early. But when we detect it early, the next problem is, how do we actually get to this nodule? How do we diagnose that nodule? There are about 5 strategies that we can apply if a patient shows up with a lung nodule. We can do nothing because the overall risk in the young patient seems almost negligible, that we need to do anything. It's like, look, it's most likely nothing. Or we say, come back in 3 months or 6 months, and we get another scan and see if that mass grew. Or we can use a conventional bronchoscopic technology through the mouth, less invasive, and see if we can take a sample from that mass. We can also do surgery if the risk is very high. It's a huge mass and it looks like lung cancer. Most likely it is lung cancer. Let's do surgery straight ahead and then continue with doing the therapy. The problem here is if it turns out not to be cancer for those intermediate sized nodules, then we did unnecessary invasive surgery on patients that had a benign condition, right? And the last is robotic assisted bronchoscopy. And so our idea from the beginning on with ION was to enable physicians to reach endoluminally everywhere in the lung through the most tortuous pathways into the periphery of the lung where we find these early small lung nodules and enable them to take tissue samples from defined areas. That was the idea all along. And at the same time, have a very positive safety profile. So we don't want to cause any harm. There are other technologies where you advance biopsy tools through the chest wall. That allows you precisely position under 3-dimensional imaging, under a CAT scan, to position the needle, but you have to cross the chest wall. You have to cross the linings of the lung, and that might cause the lung to collapse and cause harm to the patient, something we don't want, right? So we wanted to advance the technology, enable the physicians to get everywhere in the lung and do not cause any harm. So they don't need to worry which technology do I use now for this patient. And the decision-making in the past has been guided by the size of the nodule, the location of the nodule, the probability of cancer of the nodule, access, and the patient desire, right? And our idea was to replace that. And it's, look, you have one tool that allows you to do that all safely and enables you to collect lung tissue where you want to collect lung tissue.
Great. Well, let's talk a bit about the technology. Charlie, how does ION's technology complete these tasks? And how does it differ from Da Vinci? If you look at the videos you have online, it's a completely different sort of approach into the body, and obviously it needs to be.
Yeah, everyone always says, oh, it's completely different. I would say we actually leveraged a great part of the robotic system that we'd already invented.
Oh, okay.
And, the drive mechanism, the ability to precisely control the movement of the catheter actually comes from the way we drive instruments with Da Vinci. What's different, of course, and 2 obvious differences, right? It's flexible. So we have to navigate, round the tortuous anatomy, as Oliver said, all the way to the periphery of the lung. So it's not a straight shot. So you have to be able to have that sort of precise robotic control on something that is bendy, inherently flexible. So that's tricky. And then the other thing, of course, is to get to the periphery of the lung, we need to be as small as possible. And those 2 things are really, as Oliver said, the limitations of manual bronchoscopy. Manual bronchoscopes are large, They're operated by a physician standing over the patient, trying to navigate. And the other thing that they don't have is they don't have a map. And that's where the sort of real difference is. So think of taking all the learning from Da Vinci, and then what we added was navigation. We take the CT scan and we basically make like a Google map to the lesion. It's a 3D Google map. And then in order for us to actually know where the catheter is, we took shape sensing, so a fiber that can detect the movement with reference to where it is in the lung. And so we combine these sort of three things. So navigation isn't new. And obviously we're, the kind of Bay Area medtech goes straight to the software solution. The control of the catheter isn't new. We took that from Da Vinci. The shape sensing is new and really the heart of the device. Combine them all together, and we ended up with a 3.5 millimeter flexible catheter that, most physicians can learn pretty quickly and drive to the nodule. That is something people are like, oh, that's it. I'm like, that is mostly impossible today. You can't get a bronchoscope to the periphery of the lung. And even if you made one small enough, being able to actually navigate there would take so long that it would probably be cost prohibitive. So that's sort of the heart of the tech. And the beauty is once you get there, you can take your hands off and it stays exactly where it is. And that's a simple thing too, but think what that physician can then do with their hands. And so that's the sort of power of the robot, right? Is it stays where it is. And so now you've got a tech which takes everything from Da Vinci, and it was a seed planted 10 years ago. It isn't much talked about, as you said, but it grew into a big tree. It grew with all the benefit of learning from Da Vinci and many of the people. And if you look at my team, I lead a team of 300 plus engineers that help make it. I mean, they've been working for 10 years to create a robotic bronchoscope, and now it's here. And it does what it says on the tin. It allows thoracic surgeons and IPs to get to the periphery of the lung. And as Oliver said, to sample nodules that are as small as 5 millimeter. Whereas in the past, as Oliver said, most of the time, if they were that small, you were told to wait. Waiting means upstaging cancer. Waiting is terrible. Why would anyone want to wait? And so here it is.
That's great. Oliver, I want to talk to you for a moment about the difference, but Charlie, I do want to just circle back. Talk a bit about the shape sensing, because that was an interesting component, that it sort of registers its location in the body. Was every second or so? It's sort of
it's every fraction.
It's pinging you.
It's every fraction of a minute. It's milliseconds, not seconds. Okay. It's actually the same sort of fiber that is used in telecoms to give us internet all around the world. What happens is, as you bend the fiber, obviously the light changes in the way that it moves through, and you can actually sense the position. And so it's pretty complicated. It's a grating that allows you to actually read that. And then we have to ground that, right? So we have to have a reference plane. So the beauty is conventional methods are electromagnetic, and they're the alternate techs. And that doesn't play well in the OR. So not only is it as, shape fiber as good as the conventional techs, but it's completely free from interference, which is really sort of game changer in terms of being able to use all the other things in the OR.
Very cool. Oliver, talk a bit about the difference. It sounds like a dramatically different experience from using what was previously used to what's now possible with Ion.
Yeah, absolutely. As I mentioned before with my experience in the notes world, the trade-off between a flexible system when you need a flexible and a stiff system, that was the first trade-off. That was very exciting to me to see now a system that has much more stability, that I can put in a position and let my hands go and it stays in that position. Very exciting. At the same time, if we can get this flexible system as small as possible, 3.5 millimeters is almost nothing, and still have the same functionality, that was very exciting. Now we augment for the lung these capabilities with navigational capabilities. You start in the trachea, in the biggest airway, and from there on, like a tree, you have to take right turns, left turns, go up, go down, 5, 6, 7 turns. And it's really hard by just looking at a CAT scan and the nodule to know when do you have to make which turn. So for that reason, having the ability to pre-plan the whole procedure prior to the actual intervention is very helpful. So what we do is we take a CAT scan, we put all the slices, stitch them together, we extract the airways, and then we find our lung nodule and we define a path to that lung nodule. That is very helpful. And now the last piece is we have to tell the catheter, how do we get from the trachea and follow that path that I created prior to the procedure? How do I get to that lung nodule in real time? It's kind of like sitting in the car. Either you use your passenger back in the day who has a map and tells you, okay, now you have to go right or left. Or you have a navigation system that accurately tells you, okay, when you come to this crossing, take a right, now advance, take a left, right? And that was the last piece that we need ion to accomplish to get effectively into the periphery and close to those lung nodules. So a combination of different technologies that didn't exist until now. That was very exciting.
And Charles, just talk briefly about the size of the console. Is it a larger piece of equipment like a larger surgical system, or is it something smaller that may be available for maybe ambulatory surgery centers or physicians' offices? How big is Ion?
About the size of a normal lap tower, if that's something that resonates. So it's much smaller, obviously, than Vinci. Typical to many things that you wheel in and out. What we want to do is make sure that it fit. There's a fair few things in the OR, right? You've got a CT scanner, you've got various other equipment. So we worked hard to make sure that it could be used in conjunction with everything else that was in the bronch suite. But you can wheel it from room to room. It's relatively easy, one person to do that.
Great. And finally, Oliver, where do we go from here with Ion? What's its future? You talked earlier about the potential for notes. What's the next step beyond the lung, and where might the system be used else in the body?
Yeah, so the lung is actually quite an interesting organ to begin with, right? There are a lot of things that can be done in the lung. If you look at the most frequent cause of death in the US prior to COVID, chronic lung conditions were on fourth place, right? So there is a lot of opportunities, not only for lung cancer, which we know is the most deadliest cancer in the world, but also chronic benign lung conditions is in our interest. In the beginning with lung cancer, we intend to enable physicians to retrieve tissue samples from cancer so they can give it to their pathologist, who hopefully can tell them what the condition is. Once we know what the condition is for cancer, maybe there's an opportunity, we can provide a tool to physicians to actually implement Ion in its technology to treat those conditions as well, right? Whether that's cancer or whether that's a benign condition. We're closely looking into the opportunities here. We know there are other parties that are looking into similar things. And in everybody's mind is whenever you decide on a new treatment, keep it minimum invasively. You don't want to have maximum invasive treatment, even if it's effective. Let's try to stay as minimum invasive as possible. And the endoluminal route is predestined for that. And what we do is we allow to drive everywhere in the lung and have an open platform. We have a tool channel within our catheter, and you can advance tools through that tool channel. Whatever that tool in the end does, that remains to be seen, or what it should do, that remains to be seen. But in the end, we are an open platform and enable either our own technologies or third-party technologies. So that's very interesting. There is a lot that we can do in the lung. And obviously, there are other areas outside the lung. As I mentioned before, my previous career, foreguts of the upper part of the intestinal tract, that was my specialty before. There are interesting parts. And everywhere else where you have an orifice and you can insert an endoscope is of interest, right? So I think the future is very bright.
Great.
I was going to add to that, Tom. I think the first step is the idea of access, right? Manual access to the lung has limited the development of technologies to treat in the lung. It's like chicken and egg. And so we very much see Ion as saying, okay, there's a new standard for access to the lung. I'd expect in the future for robotic access to the lung to be the standard of care. Once you've done that, now we're sampling all these much smaller lesions. The thing we do today actually is those patients, if that diagnosis turns out to be positive, they go straight to surgery. Often they go straight to Da Vinci surgery. And in fact, we've had more than 50 where they go in the same procedure and have the cancer removed, which is amazing. So you think like, you don't have to fast forward. Today, We do that. Patients go in for biopsy of a very small nodule. If it's not cancer, they go home. If it is cancer, they've gone in and had it removed with Da Vinci and not had cancer and gone home. That's today. We do that with the two platforms. And you can imagine as you look forward, now that is going to make, I have to believe that's going to make robotic access the standard of care. Once robotic access is easier, then not just us, but as Oliver said, all companies who are looking to do treatment in the lung are going to be able to do new things, right? Previously limited by manual bronchoscope. Now they've got this super stable platform and go anywhere in the lung with a 2 millimeter working channel. And the opportunities, not just from a device standpoint, from a drug, immunotherapy, imagine what you can do inside the lung through ion. And as Oliver said, we've been very clear to say, we want to make this paradigm shift. Okay, here is access to the lung redefined. Now let's have at it in terms of developing tools to treat there. And we intend to do that. We've been very clear that we want to be open access, just like manual bronchoscopes are today. That should enable everybody that has a good idea to treat in the lung to use our system. And I think that's an interesting paradigm. I think it's one that's very patient first, right? We're not going to say, hey, Intuitive has all the ideas for solving everything in the lung. We don't. We want our platform to enable, ourselves and everybody to make that transition. As Oliver said, ultimately, someone will say, well, won't that stop Da Vinci thoracic surgery? And I'd say, yeah, that's great. Some of those surgeries don't need to be performed. Interestingly, if we catch so much more cancer stage 1A, we'll do more surgery too, because it will be an option. At the moment, it isn't. So I think the future's really bright. I think the demand's going to grow. I think we've sort of broken a paradigm that you can't get to the lung and do other things. Now you can.
That's great. Now, in this conversation reminds me, you talked about notes and its emergence a decade or so ago. At the same time, we had a lot of interventional pulmonology tools that were coming about. Does that become an option for a better way of maybe delivering those, which had mixed results, but maybe this is sort of the key to helping those work and treating COPD and other conditions?
Yeah, I think the journey is similar. We often get compared to that change in cardiovascular surgery about that time. We also look at what's happened in breast and prostate cancer as technology's got better for diagnosing earlier. I think all of those should apply. You should join those two together. Let's get survivability up. Let's make it a lot easier. You shouldn't have to go and see, a cardiovascular surgeon. You shouldn't need to see a thoracic surgeon if there's an easier way. So yeah, we get that all the time. Oliver can talk. It's a fun challenge having multiple customers, but there's space for everyone.
Oliver, anything more to add on where we're headed?
I fully agree. I want to direct a little bit the focus on, we are still not done with what we're doing today. And we have to keep our focus on finishing that journey where we are today, in addition to looking and exploring other opportunities, right? Today, patients, we looked at data, we saw that close to 50% of patients in the US require more than one biopsy until they get a definitive answer, right? First, you're confronted with a situation, the physician tells you, we found something on your lung, we don't know what it is. Now there is a process. What do we do with that? We watch and wait, come back in 3 months. Now we decide we get a biopsy. Okay, now we get the first biopsy and it's negative, or we couldn't get any conclusive tissue. What do we do? Now we do this again, find a different modality. That is stressful for patients, right? And always with the idea in the back of your head that this might be lung cancer. So there's a lot that needs to be done. We want to take away the fear of patients immediately once they have been identified with a lung nodule to tell them what it is. And that's a journey we started, but we haven't finished yet, but this is where we want to go. And we're not losing focus on that before we moving on to other endeavors. It's important to the patient. For that reason, it's important to us. We want to reduce the time to treat. We want to reduce all the technologies that are needed to get to an early treatment. And we want to make that journey as straightforward as we can for our patients.
Yeah, I would add to that. I think you're spot on, Oliver. It's in our DNA, right? We will never stop trying to make our robots and tools the best they can be. And Oliver's right. We have to be the best access. We have to be the best at getting to those lesions and diagnosing them. The 90s, high 90s, as high as we can go. Because once you lose that, then, you go on and try and do something else. Well, you started from a poor place. And I think, it's very much how we think here is, we never settle. We're constantly trying to improve the performance, reliability. We have to be the best robotic bronchoscope. And we have to be that first. And we're just, we're just starting there. I really think you do that, and then the floodgates open.
Fantastic. Well, it's a great story. Thank you. Thank you both for sharing your sides and your insights. And thanks for being on the podcast.
Thank you so much, Tom.
Thanks, Tom.
All right, well, that is a wrap. Thank you so much for joining us on this episode of Intuitive Talks. Thanks, of course, to our guests, Charlie Dean and Oliver Wagner of Intuitive, and our sponsor, Maxon. Please, if you would, share this episode of Intuitive Talks on your social media channels. And when you do, please tag me and connect with me. I am on Twitter at MedTechTom. I am on LinkedIn, Tom Salemi, Salemi. You can find this episode of Intuitive Talks and past episodes of Intuitive Talks in our other podcasts at devicetalks.com. You can also find out information about our other programs, including in-person events, which are starting back this year. Finally, please don't forget to subscribe to this podcast. You can push the follow or subscribe button, and you'll get future episodes of Intuitive Talks and our other podcasts sent directly to you. That's it. Thanks again for joining us on this episode of the Intuitive Talks podcast.